students. Today we are going to discuss the topic probability. Here the content of the topic. First, introduction, then axioms on probability, basic concepts with certain examples, property, conditional probability, Bayes theorem, and applications of probability in real life. Probability is a branch of mathematics that deals with calculating the likelihood of a given event occurrence, which is expressed as a number between 0 and 1. An event with a probability of 1 can be considered as a certainty, and an event with probability of 0 can be considered as an impossibility. Look at the picture. This is an example for certain and impossible event. Getting 14 while rolling the dice is an impossible event, whereas the sunrise will occur every day is a certain event. And getting the head or tail is an even chance of possibility. Let me teach you some basic concepts in probability. Random experiment. Random experiment is nothing but the result depends on a chance. Trial. Trial is performing a random experiment. An outcome is a result of a random experiment. Event is an outcome of a random experiment. Okay, here are the few examples: tossing a coin, throwing a dice, and select. Next, sample space. Sample space is a set of all possible outcomes of an experiment. Here is the example for sample space. While throwing two dice, here we will get the following sample space. Here is the axioms of probability. Axiom 1 says that P of A greater than or equal to 0 for any event A. Axiom 2, P of X is equal to 1, whereas is the sample space. Axiom 3 says if all AIs are mutually exclusive, then probability of A1 union A2 union etc. up to AK is equal to summation I varies from 1 to K P of AI. Here the set is finite set. If the sets are infinite, then P of A1 union A2 union etc. is equal to summation I varies from 1 to infinity P of AI. Next, let me explain few properties of probability. The first property is for any event A, P of A is equal to 1 minus P of A complement. Second property is if A and B are mutually exclusive, then P of A intersection B is equal to 0. The third property is otherwise called as the addition theorem on probability, and it says that P of A union B is equal to P of A plus P of B minus P of A intersection B. Next, let me explain few definitions in this. First one is equally likely event. Equally likely event is nothing but the equal chance of occurrence. Look at the picture, and in this picture, selecting a blue or red ball is equally likely event. Next definition, mutually exclusive event. Mutually exclusive event does not occur simultaneously, and this is the example for mutually exclusive event. Pink, red, and green at the same time. Next, independent event. Independent event is nothing but the occurrence of one event does not affect the occurrence of the other. Events A and B are said to be independent events if and only if P of A intersection B is equal to P of A into P of B. Here is the example for independent events. A coin is tossed and a card is selected are independent events. Now let me explain how mutually exclusive event differs from independent events. Mutually exclusive and independent events are almost opposite to each other. If they are mutually exclusive, then if one happens, other cannot happen. That is, they are quite opposite to each other. Whereas independent essentially means that if one event happens, it has no effect on whether the other event happens. Now, here this is the example for mutually exclusive events. Look at the picture. The one is dog and the other is cat. Now, let me take P of A as the likelihood that an animal is a cat. Let P of B is equal to the likelihood that an animal is a dog. Now, when we take the intersection between these two, that is P of A intersection B is exactly equal to 0 because it is impossible for an animal to be are both dog and a cat. This is a simple example for independent event, owning a dog and growing your own herb garden. Both does not affect each other, so this is the example for independent event. Another definition is complementary event. Event and its complementary does not occur simultaneously. Let me give you an example. When you throw a dice, getting an odd number and even number are complementary to each other. Now the definition of conditional probability. For any two events A and B, P of B greater than 0, the conditional probability of A given that B has occurred is defined by P of A given B is equal to P of A intersection B divided by P of B, provided P of B is strictly greater than 0, which can be written as P of A intersection B is equal to P of B into P of A given B. Let me explain an example for conditional probability. This is a problem. A family has two children. Given that one of the children is a boy, what is the probability that the other child is also a boy? There are four possibilities of outcome. The first one is boy and the girl. The second one is boy and the boy. The third one is girl and the boy. The fourth one is girl and the girl. Let me define the event B. Let B be the event that one child is a boy. Then the possibilities are boy and girl, boy and boy, girl and boy. That is P of B is equal to 3 by 4. We have already seen that the possibilities of outcomes are 4. Let me define the event A. Let A be the event that the second child is also a boy. Then the intersection between A and B is 1. That is the probability of A intersection B is equal to 1 by 4. Now, let's find the solution for the given problem. Given that the first child is boy, then the probability that the second child is also boy is given as P of A given B is equal to P of A intersection B divided by P of B. Here the value of P of A intersection B is equal to 1 by 4, that is 0.25, and the probability of B is 3 by 4, which is 0.75. So when you divide 0.25 divided by 0.75, then the answer for this is 1 by 3. Next I am going to teach you Bayes theorem. Bayes theorem is a very famous theorem in statistics, and it was originally stated by Thomas Bayes. Statement of Bayes theorem. Let A1, A2, etc. A, K, B collection of K mutually exclusive and exactive events with P of AI greater than 0 for I varies from 1 to etc. K. Then for any other event B for which P of B is greater than 0 given by P of AI given B is equal to P of AI into P of B given AI divided by summation I vary from 1 to K P of AI into P of B given AI. This is a problem based on Bayes theorem. A laptop is manufactured by three companies A, B and C. Of the total output, company A is responsible for 25%, company B for 35% and company C for the rest. 5% of the output from the company A is defective, 4% from company B and 2% from company C is defective. A laptop is chosen at random from the output and found to be defective. What is the probability that it came from company A? Let me define the event B, that is laptop is defective, and event A as the laptop manufactured from company A, B the event laptop is manufactured from company B, and C the event laptop is manufactured from company C. Now P of A is equal to 0.25, P of B is equal to 0.35 and P of C is equal to 0.4. Now let me discuss the defective product. Here P of B given A is 0.05, P of B given B is equal to 0.04 and P of B given C is equal to 0.02. From the statement of Bayes theorem, P of A given D is equal to P of D given A into P of A divided by P of D given A into P of A plus P of D given B into P of B plus P of D given C into P of C. Now let's substitute the values of P of D given A into P of A, which is 0.05 into 0.25 divided by 0.05 into 0.25 plus 0.04 into 0.35 plus 0.02 into 0.4. So when you simplify the value, you will get it as 0.362, which is the required answer for the given problem. Here are the few applications of probability in real life. We use probability in daily life to make decisions. Probability theory is applied in many ways in our today life. Few applications are given below: weather forecasting, sports, insurance policy, forecasting sales, and medical field. The theory of probability is beneficial because we can compare the outcomes with observed events and evaluate the efficiency of our research. We are also able to make a quick prediction as to what the result will be. Hope you enjoyed the section. Thank you.